Hi, welcome to Chapter 6. We're going to get into this thing called classes. Now, we've been dealing with classes for quite some time, uh, and we'll get more into that. But in the book, it says an object is a software component that exists in memory and serves as a specific purpose in a program. An object is created from a class that contains code describing the object. So that last sentence is really the most important part of this. An object is created from a class that contains code describing the object. So we've done this, and so let's see. I think I got an example here. Well, we'll talk about that in a second. But let's talk about what a class is. Now, a class is I want you to think of blueprints to build a house. So we got these blueprints, and I can create many houses from this set of blueprints. And that's basically, I want you to think of a class being that. It's a blueprint for an object. We got this blueprint, we create an object from it. We create another object, we create another object, create another object. So let's kind of dive a little deeper into this. And so the first thing I want us to look at is let's take a look at this code called object demo. And this basically does what I just talked about a few minutes ago, where we've got a scanner keyboard. Now, scanner is a class. We're creating an object from that class called a keyboard. And again, remember, on the left-hand side is it creates the object. It's an empty shell of an object. On the right-hand side, when we do equal new and then whatever that class name is, that basically fills in all of the different methods and different variables and all that kind of thing. And so now when I execute line 19 right here, I now have an object called a keyboard. Now, I've talked about this before, so down here my keyboard has been created and I've got a period. If I type a period next to it, you'll notice I see all of these other methods and all of these other things that come with this class. And those all get basically put in on the new scanner up here. So there's a lot of stuff that comes with this class that we create, this object. Same thing with random. I create a random. Brand is now the object, and it's instantiated as a new random, so it basically fills in with all of the different stuff that's inside of this class. And again, if we go out to the Java API, and I look up random, the random class over here. So here's random. And here is all the stuff that comes with it. Look, here's all of the methods. These are all of the methods that come with the random class. Okay, this is all pre-written code that we get to utilize when we create a random object. And so all of those basically show up right down here. So here's my random object called rand. And when I type a period next to it, all of these methods right here are basically showing up over here in this random class. Okay, so let's kind of dive a little more and see about how can we create our own class. Okay. So the very first thing it talks about is primitive variables versus objects. Now, primitive variable is just that. It's just numeric. That's all you get when you basically create a variable that is a primitive data type. I like down here it says, primitive variables such as ints, doubles, and so forth are simply storage locations in the computer's memory. There's nothing else that's there. It's just, I talked about before, it's just a Tupperware container that contains. So if I got this int Tupperware container, the only thing that can go in there are ints. If I got a double, that's the only thing that can go in there are doubles. I can't put ints. Well, I can try to put ints into a double. But again, we talked about that before, like putting a round peg in a round hole. Depending on the size of that peg, it won't fit that hole. So again, that kind of, remember we talked about casting, but we have to, so that's really all you get. When you create an integer variable, that's all that's there is an integer variable. But when we create an object, we get a whole lot more. I don't like this example too much, but let's just talk about it. They call it a kite and string metaphor. So the object is the kite, and the variable referencing the object is the string. And so it basically, let's skip that. It's bad. So what they're trying to say here is we declare a reference variable. We create an object in memory that assigns memory to the reference variable, which basically is kind of the kite, and then the reference object is the string that controls it. Again, that's kind of a bad example. I don't really care for it. So let's talk about writing a class step by step. So what the example we're going to use in this case is we're going to have a rectangle. And a rectangle has two variables inside of it called length and width. Okay. Now, inside of that class, we need to be able to do things like put data into the length and put data into the width. We also need to be able to get data from that length and get data from that width. And so the very first thing to talk about is this thing called the UML diagram. So if I were to document what needs to be done, the very first thing we do is we'd create a UML diagram. And it's basically a box with three separate sections. The first section is where the name of the class goes into. The next section is where the fields go into. And then the last section is where the variable, the methods go into. And so here we have our rectangle class. We've got our length and our width. Those are our variables, our fields. And then down here I've got my set length, our set width, our get length, our get width, and we got another one called get area. Okay. So let's see what that looks like. So the very first thing we'll notice is when we create our fields, we have private in front of them. Now, the reason we want them private is if they were made public, then people would, or other programs would have direct access to those variables. No, we don't want to be able to have direct access to it. We need to control how they have access to that variable. So we create them private. Okay. They're both going to be doubles. One's called the length, one's called the width. Okay. We come down here. So private, when private access specifier is applied to a class member, that member cannot be accessed by code outside of the class. When it's public, it can be accessed outside of the class. And then we need to write the set length method. So let's take a look at the very first rectangle. I have those broken up into phase 1 through phase 5. So if we expand phase 1 and I look at rectangle, we can see that we have private double length, private double width. And down here I have this variable called public void set length. Now notice it's public, so it's basically we can access it from outside of this class. Void means nothing being returned. Set length is the name of the method, and then I have double len, so I'm having a double passed in, and in here I say this length, this field up here, length, is going to be set to whatever's passed into this particular item. So we look at the length demo, and here I create a rectangle. So where's that rectangle at? Well, it's over here inside of this package. And we're going to basically call this object called box, and it's going to be instantiated as a new rectangle. So on the left-hand side, we create an empty shell of an object called box. On the right-hand side, those two fields, and that method is going to be loaded into it. Down here, I can say I'm sending the value 10.0 to the set length method. So down here, look at this. I got box.setLength. Now notice when I type a period behind box, notice I get some other things. We always have some defaults. We'll talk about those in a little bit. But there are some defaults that come with it. And that's because every class inherits from another class, and so all of those methods come with it automatically. But the one thing we will notice is we have this set length. It's got a double len in it. That's the one that we basically wrote inside of our class over here. So now I say box.setLength 10.0. What's that going to do is that 10.0 is going to be inserted into the length field, and then I'm going to just say done. It really doesn't do more than that. So when I run it, it just basically says sending the value 10.0 to the setLength method, done. So let's do this. I'm going to come over here and I'm going to delete this guy. And we're going to create our own class. So let's do that. So I'm going to come over here to the chapter 6, the chap 6 package. I'm going to do a right click. I'm going to point to new, and I'm going to click class. I'm going to call this rectangle. I'm going to leave the public static void main unchecked because this is a class and this is not going to be executable. So we're going to click finish. So now we have our package chap 6 and I've got my public class rectangle. So I'm going to come over here and I'm going to create my two fields, private double length and private double width. Now, so here's kind of how a class works. We have to have some place to store the data, and that is going to be stored in these two variables. Now, these variables are called instance variables, okay? And what are reference variables. Right, reference variables. And what that means is these guys hold the data for this class. So when we need to store something in this class, they're going to be stored in those two variables. Now, in order to get data to put into those variables and get data out of those variables, we need these methods that are called accessor and mutator methods. Mutator methods are basically saying we're going to mutate this by actually putting data into them. That's called the mutator method. And when I need to get data out of them, we call them the accessor methods. Now the shortcut for these guys, the nickname, is called the getters and setters. Now the really easiest way to do that is once I have my variables created, is I come up here to source and I come down here and there's generate getters and setters. So I click on that and it says which two instance variables do you want these instance variables. I think I told you it wrong before. It's called instance variables. Is we put a check mark in those two boxes and I click generate, and look at that. It automatically created a public double get length, and it returns the length. I've got public void set length. We're going to pass in a double. And notice it's got the word length in there. Well, guess what? If I'm going to take this dot out of there, is if I click on that length, notice it highlights all three of those because those are all the same variable. Notice when I click on this length, see how it says return length? That basically is associated with the instance variable. What I need to do is every class has its own nickname, and that is the word this. So when I'm inside of a class, if I use the word this, I'm talking about the class that I'm currently inside of. So if I type this dot, notice it's got length and width. Those are my two instance variables. And now, when I click on this length, it's talking about this instance variable length, okay? Now, in the example we just saw in the previous one, they had a len right here. They kept them separate, and we could have done the same thing, but when we use the getters and setters, it actually uses the same exact name, so that way we're forced to use the this dot to basically reference that particular instance variable. I have the same thing for get width, which returns the width, and I've got set width, and again we're going to pass in a double, and this dot width is equal to width. So this width refers to that. When I click on this width, it refers to the instance variable. Okay, now that's as simple as it gets for basically creating a class. So now I have my instance variables, they hold the data, and here's my accessor and mutator methods, otherwise known as getters and setters. They allow me to put data into those variables and allows me to get data out of those variables. Okay, and that's why these guys are private, because we can control this. So what if we did this? What if I got rid of the getters and I just had setters in here? Well, that makes those variables write only. We cannot read them. And we could do the opposite there as well, is we could just get rid of the setters and keep the getters, and now I can get the data, but I can't write to it. So again, we have control. With this class, we have the control of how people access these two instance variables. Now, the last thing that they wanted is they had one called getArea. So we're going to do public double, because we're going to return a double, and it's going to be getArea. We're not going to pass anything into it, except we're going to return length. I'm going to type this dot length times this dot width. So now we can call getArea, and it's going to grab the length, the instance for whatever in length in the instance variable, whatever's in width, multiply them together and return that. Okay, so now I'm going to create a new, do a right click and point to new, and I'm going to click class. I'm going to call this rec demo for rectangle demo, and now I'm going to need my public static void main. And I click finish, and now inside of my method I'm going to type rectangle rec is equal to a new rectangle, left and right parenthesis. Then I can come down here and say rec dot set length, and in there I'm going to put in 10.0, and rec dot set width, we're going to make that 15.0. And then I can come down here and say I'm going to do a sys out, and I'm going to basically say the length equals, and then I'm going to concatenate on rec dot get length. I'm going to do the same thing for width, SYS O, control space, enter, width equals rec dot get width. And then I'm going to do one more SYSO. And area equals rec dot get area. That's as simple as it gets. So we created a class called rectangle. In there we have two instance variables, length and width. We have getters and setters, a setter for each of those to put data into those instance variables, and then getters to get data out of those variables. And then we have one more method where it actually calculates the area of that. So now when I run this, the length, I forgot the area. So length is 10.0, width is 15.0, and the area is 150.0. So that's a very simple class called rectangle. It's got two instance variables. It's got a getter and setter for each reference variable, and then it has a getArea method to calculate the area of that. So here's what's kind of cool is, let's see, I think we got a whole lot of stuff to get through on this book, so I've covered a lot. There's the set, the get. Yeah. Yeah. Yeah, I covered all this with my. Now, one thing I do want to kind of stress here is this thing called avoiding stale data. And one thing is, what students want to do is I want to go ahead and create a private double area, and we'll have something called public void set area, and then I'll say area is equal to length times width. Okay, and then oh, I accidentally. Okay, so I got that, and then I'm going to go ahead and comment this guy out, and I'm going to say return area. Okay. Now this is going to work. It's going to work until we change the length and area. And what do I mean by that? So let's say we come in, we've got our length set to 10, our width set to 15. I do that through my setter. And then I come down here and I call set area. So it basically says area is now equal length times width. Okay. I can then call get area and it's going to return 150. Now I come in here and I change length to 20 and I change width to 10. I can call the getters for each of those lengths and widths, but look what happens when I call get area. It's going to return 150 when it's now 200. So what we want to do is we want to avoid doing that, because, so let's actually see an example of this. So we've got our set length, set width. We get the length, we get the width, we get the area. Okay. need to do one more. I'm going to need to call rec.set area, and that's all I need to do there. Okay. So I'm just going to go ahead and call this, and we get the same exact results. Okay. I wasn't expecting anything different. Then now I'm going to come down here and I'm going to say and I'm going to copy these three again. And so now I've set the length to 20, and that is set to 10. And now watch what happens when we run it again. So length is now 20, the width is now 10, and the area is still 150. That's because that got stale. In order to keep it from not getting stale, what we want to do is basically get rid of this guy, keep that where it does a calculation. I'm going to get rid of that instance variable. We don't need an instance variable to hold that. We are going to let the get area be our display, and it's always going to make sure. So now if I come back to my rec demo, I'm going to get rid of this set area now. We're always going to get the freshest data that there is, because our get area always does a calculation of multiplying length times width. So now when it runs, notice now its length is 20, width is 10, the area is now 200. The old way, I'd always have to make sure I always called the set area. Whenever I change length to width, I have to make sure I call, and there's no need for it. If we just use the get area to do the multiplication for us, we never have to worry about stale data. And that's kind of what they're talking about there on that page when they're talking about stale data. Okay. So now let's kind of update our UML diagram. And UML, again, stands for Universal Modeling Language. And what that does is now we got these minus signs and plus signs. And what they show is minus signs show private and plus signs are public. So we got minus, which is our private, which is, again, what we always want to make sure that we keep our instance variables private so that we control how they're accessed. And we do that through our getters and setters. Now, another thing we want to do is we also need to basically show their data types and also what's being passed. Okay? And so the way we do that is now I say minus length, which means a private length, and it's a double. Width is also a double. And we got set length. We're going to show what's being passed in. A variable called len, it's double, it's passing back a void. The width is receiving a double variable called w, it's passing back nothing, which is void. The get length is passing back a double, nothing's being passed in. Width, nothing's being passed in, it's passing back a double, and same thing with area. So, in our classes, we always do our field declarations at the top, and then we do our method declarations or definitions at the bottom. Okay. So let's say we got a car, we got a make, year model, set year model, get make, get year model. Okay. And so instance fields and methods. So each instance of a class has its own set of fields, which are known as instance fields or instance variables. You can create several instances of a class and store different values in each field. The methods that operate on instance are known as instance methods. Okay? So let's take a look at rooms area. I think that is... Yeah, there we go. Phase 4. So I'll look at rooms area. So in here, I'm going to look at rectangle first. So let's take a look at rectangle. So here's our rectangle. We've got our length and our width. We've got our set length, set width, get width, and then we got get area. I could use so here is my standard rectangle demo. Okay, and we basically pass in 10 and 20. We can get the length, we can get the width, we can get the area. We've seen that. So here's the next thing I want to do. Let's take a look at room area. So I'm going to have some 3 local variables, double number, double total area, and we got string input. So I'm going to create 3 rectangle objects. I got a rectangle kitchen, it's instantiated as a new rectangle. Rectangle bedroom, instantiated as a new rectangle, and rectangle den as a new rectangle. So now I got 3 objects from the one class. One class was my blueprint to create 3 objects, a kitchen, a bedroom, and a den. I'm going to use a J-option pane to say what is the kitchen's length. I put that in input. I have to convert that string into a double and put it into number. And then I'm going to say kitchen.setLength is equal to number. Okay. So that's going to call the setter for this rectangle. It's going to call the set length. Whatever's passed in as a double is going to be put into the length instance variable for that object, which is the kitchen at this time. I'm going to do the same thing for the width. I'm going to do the same thing for the bedrooms. I'm going to set the length and width for the bedroom and the length and width for the den as well. Okay, so I'm using the J-option pane to do that for those 3 rooms. So I'm going to get the length for each room, width for each room, and basically use the mutator methods, the setter methods, to put that data into those instance variables. Down here, though, I'm going to say total area is equal to kitchen.getArea plus bedroom.getArea plus den.getArea. So the get area is going to multiply the length and width for each of those objects, add them together, and put it into total area. Then we're going to use a J-option pane show message dialog and say the total area of the rooms is, and we're going to display the total area. So let's run this. What's the kitchen's length? We'll say it's 12 by 8. The bedroom's length is 15 by 10. And the den's length is 13 by 11. And if we were to basically do the calculations and get the area for each one of those, we see that the total area of the rooms is 389 feet. So pretty cool. So the whole point of that exercise is to let you know that, look at this, we created 3 objects from that rectangle class. So we now have 3 separate objects, and each of those objects has their own set of instance variables, and each one of those objects has their own getters and setters, and in this case they have a get area method as well. Okay, so this next section is all about something called constructors. Now, it says a constructor is a method that is automatically called when an object is created. So if we take a look at phase 5, rectangle. So in here, I've got my class rectangle, and here's my private double length, private double width. No change there. But we'll notice right here I now have what's called public rectangle, left and right parenthesis. You'll notice that it's, remember how we always said methods always start with the lowercase? Well, you notice this one starts with an uppercase, and it has the same exact name as the class. This is what is called a constructor. It's a method. When does it get called? Now, another thing you'll notice, it returns nothing. Constructors always return nothing. That's why we don't put anything in here. We don't put void. We don't put anything in here because it always returns nothing. When is it called? Well, we'll talk about that in a second. But look what this constructor does. It sets the length to 5 and the width to 15. You'll notice we have our setters, we have our getters, and we have our get area. Let's take a look at the constructor demo. So you notice in here we got rectangle box equals new rectangle. So it created a box object, which is a rectangle object. And you'll notice that the next thing it says is the box length is box.getLength. When did that constructor get called? It got called right here on line 13. Notice this parentheses right here. This parentheses is basically what is being passed to the constructor. You'll notice our constructor has nothing inside of it, and so nothing's being passed to the constructor. What it does is it actually executes the constructor. This is what's called as a no argument constructor. Now, let me say this. Every class has a constructor. If we look over here at this, one of the first rectangle classes were created, you'll notice we don't have one. But trust me, one is there. It did absolutely nothing. This is basically what this constructor looks like. It says public rectangle, left and right parentheses, an open brace and a closed brace, and that's it. It did absolutely nothing. So every class has a constructor that looks like this. It's unwritten, but it's there behind the scenes. In this particular case, this rectangle, when it's instantiated, it sets the length to 5 and it sets the width to 15. So we don't have to set any of those. So now when I run this particular item, it says the box length is 5, the box width is 15, and the box area is 75. It didn't ask us for any data. We didn't supply any data. The rectangle class itself set that. Now, we probably would never do that. We always want to use the setters to basically set those. But here's the thing, is we could come down here later on and say box.set length and set that to 15, and box.set width to 25. And then I can come through here and display those again. So I can change it after the fact, but just when I first instantiated this box object is when those two get set in the constructor. So now let's take a look at the UML diagram. Now we've got our constructor in here. So we've got rectangle, here's our length and width. We show the doubles for each. And now we've got rectangle, and we're passing in len, which is a double, and w, which is a double. Notice it's not passing anything back. Notice it has the same exact name as our class. We know that that is the constructor. I just talked about the default constructor. It says when an object is created, a constructor is always called. Even though it's not there, we basically call it, and it does absolutely nothing. Now we just wrote a no argument constructor, a no arg constructor. Again, nothing's inside the parentheses. That is a no argument constructor. Now we have used a string class constructor. So right here I've got string name equals Joe Mahoney. Now that's the same exact thing as saying string name equals new string Joe Mahoney. The string class allows us not to have to fully instantiate it. It's a string objects are a special case in Java because they are so commonly used. Java provides numerous shortcut operations with string objects that are not possible with objects of other types. So we can actually just say string name equals Joe Mahoney. In addition to creating string objects without using a new operator, you can use the equal operator to assign values to string objects, the plus operator to concatenate strings, and so forth. Okay, so this guy is the same exact thing as this guy. They both do the same exact thing. So let's take a look at the, I like these little in the spotlights. It's called creating a cell phone class. It says Wireless Solutions Inc. is a business that sells cell phones and wireless services. You're a programmer in the company's information technology department, and your team is designing a program to manage all of the cell phones in your inventory. You've been asked to design a class that represents a cell phone. The data you should keep in the instance fields are as follows: the name of the phone's manufacturer, the phone's model number, and the phone's retail price. The class should also have the following methods: a constructor that accepts arguments from the manufacturer, model number, and retail price, a set manufacturer, a set model, a set retail price, a get manufacturer, a get model, and a get retail price. Here's what the UML looks like. So here's our manufact, which is a string, our model, which is a string, and retail price, which is a double. Notice here cell phone and cell phone, they're identical. So that means that is the constructor. It's going to be passed in a string called man, a string called mod, and a double called price. And here's our setters and our getters. So let's take a look at the cell phone. And so here's what it looks like. So here's my private string manufact, private string model, and private double retail price. Here's my constructor. It's going to be receiving in two strings and a double. First string goes into the manufact, mod goes into the model, and price goes into the retail price. And then here's my set, my mod set. So here's my three setters, and here's my three getters. Okay. So if we take a look at the cell phone test, here's my public static void main. I got string test man, string test mod, and double test price. Here's my scanner keyboard. I'm going to basically say enter the manufacturer. I'm going to basically grab the next line, put it into test man, enter the model number, get the next line, put it to test mod, and then enter the retail price, grab that double, throw it into test price. Then I'm going to look at this. I'm creating my cell phone called phone. I'm instantiating as a new cell phone. Now, look at this. I'm actually having the test man, test mod, and test price in my constructor as I'm instantiating this. Because why? My cell phone is expecting those three items to be passed in the constructor. If I were to take these out, watch what happens. I now have a red squiggly line, and that squiggly line tells me, if I hover over it, says, hey, you better add the arguments to match the cell phone string double. It says, hey, your constructor is expecting those, so you better have them. So we better put those back in. And now look at this. I'm going to print a blank line, and I'm going to print, here are the data you provided. Manufacturer, phone.getManufact. Model number, phone.getModel. Retail price, phone.getRetail price. Now you will notice we did not utilize any of the setters. We only utilized the getters in this case. We used our constructor to set those three variables. And that's totally legal. We can do that. So let's run it. And we're into the manufacturer, which is Samsung. Model number is a S22, and the retail price is $799.99. Hit the enter key, and here's the data you provided. Manufacturer is Samsung, model number is S22, retail price is $799.99. So the whole point of that is to show you that we can utilize our constructor to receive data as well. But whatever's inside of this parentheses better match what's inside of this parentheses when we try to instantiate that new object. Okay. Now let's continue on our in the spotlight, and that basically is our dice. This is kind of a fun one. So dice traditionally have 6 sides representing 1 through 6. Some games, however, use dice that have different sides. For example, Dungeons and Dragons use dice with 4, 6, 8, 10, and 12, and 20 sides. So we need to write a program that allows us to have dice of different sides. So here's our our die class we're going to utilize. It's got sides, which is an integer, value, which is an integer. Notice we have a die constructor. They have the same exact name, and it's bringing in the num sides, which is an int. And then roll is another method. It's got empty parentheses, so nothing being passed in and nothing's being passed out. That's kind of strange. And we got get sides and get value, and they're both going to return ints. So let's take a look at die. So here we have our private int sides, private int values. These are both private. We have to have some way to set those values inside of our class. So notice here's my constructor, and it's bringing in int sides, or num sides. So when we instantiate this die object, it's going to take, it's expecting an integer to be passed in where we basically set the number of sides of the die. Then the very first thing that it does is it actually rolls the dice as well. So it calls this roll method. And what does roll do? It creates a random object, and it's going to create a random object with sides plus 1. Again, if I wanted a 6-sided die, I don't want a random number between 0 and 5 to be passed back. I want 1 and 6. So that's why we add 1 to it. And it's going to be put into value. So when we instantiate this and call this constructor, we pass in the number of sides. It also calls the roll method, which grabs a random number between 1 and the number of sides, and then it puts that value into the value instance variable. So when we instantiate this, it's going to tell how many sides the die has, and it's going to roll the die once, and then basically put that into value. We also have get sides and get method, or get value. So let's take a look at, I think the next one is called Dice Demo. So let's take a look at Dice Demo. And so here we've got public static void main. We've got 3 constants. die 1 side, die 2 side, max rolls. So die 1 is going to have 6 sides, die 2 is going to have 12 sides, and we're going to basically roll the dice 5 times. So what is, I create 2 die objects, die 1, and notice we pass in die 1 sides. And remember what it's going to do? It's going to set the sides instance variable to 6, and it's going to roll the dice. So we're now going to have a number between 1 and 6 and the value. Die 2 now is going to create a 12-sided die, so it's going to set its instance variable sides to 12, roll the dice, and inside a value is going to be between a number between 1 and 12. So then we say simulate the rolling of the die 1 side, 6-sided die, and the die 2 side, which is 12-sided die. Getting the value of the dice, we're going to show the die 1.get value, die 2.get value, and then we're going to say rolling the dice max roll times, which is going to say 5 times. Now we got our 4 loops. Again, remember the 3 parts. First part gets executed once at the beginning. Second one is the check at the beginning of every loop, and the last one is what happens at the end of every loop. So we're going to basically do this 5 times. We're going to roll the die, roll the die 1. We're going to roll die 1. We're going to call the method roll, which is basically simulates rolling of the dice. We're going to then call the roll method of die 2, which simulates rolling of the dice, which is basically just getting a random number. And then we're going to print die 1.get value and die 2.get value. So let's run it. And look at that. This simulates the rolling of the 6-sided die and a 12-sided die. The initial value of the dice is 5 and 7. Then the rolling of the dice 5 times. So we've got 4 and 4, 3 and 4, 3 and 10, 1 and 4, and 1 and 11. If I roll it again, we keep getting all kinds of different numbers. So, pretty cool. So, let's continue on in the book. So passing objects as arguments. So we can pass, and we've covered this before. We can pass an argument, an actual object, as an argument. And so right here we can have like this void shows die sides, die D. So we're actually passing a die object as D to this method. So let's take a look at the die argument.java. And it looks like it's going to use the die. So the die class that we just looked at, it's going to look at that. So we basically have our public static void main. We've got 2 constants. I got 6 sides, 6, and 20 sides, 20. And I'm going to create a 6-sided die. So I've got die 6 die equals new die, and it's got 6 sides. Now this is the constructor. So on this particular guy here, it's actually passing the number 6 as num sides. So when it comes into this constant right here, it's going to pass a 6 to sides. So the sides instance variable will have a number 6 in it, and then roll will actually create a random number between 1 and 6 and put that into value. Then the 20-sided die is going to do the same thing, except it's going to put a 20 in the sides instance variable. It's going to roll the die, and it's going to create a random number between 1 and 20. Then we come down here and we say roll die 6 die and roll die 20 die. So right here we are passing the actual die object down here to the roll die. So it receives it as an object. And then it comes down here and it says rolling d.get sides sided die. So in this particular case, we're now using the get sides method. So it's going to tell us what type of die we're basically rolling. And then it's going to roll that die, and then it's going to basically display the value for that die. Then it's going to do the 20-sided die and do the same exact thing. So when we look at this roll die method, it doesn't know what side of die you basically have. It knows that it's being passed a die object, but inside that die object is the number of sides, and we can get the number of sides through this get sides method. So when we run the, go ahead. Oh, it passes the entire object. So when it passes the object, it passes everything in that object. So it passes all of this stuff. All of these methods, this entire thing gets passed. But it gets passed as an object. Now, if you remember correctly, it passes the address of that object, and then right here, it creates a new object from that object. They're basically identical. They have the same exact properties and everything else. But does that answer the question now? Okay. Okay, so here's what we'll do. I'm going to go ahead and put a breakpoint right here on this sys out, so when it gets down here, we can see what's going on. So I'm going to go ahead. You can't find your what? So I'm going to run this in debug mode, and when it comes, so it's going to switch to that perspective. So now what happens, so if we look, we got the D object, and it shows that it's got 6 sides and it's got a value of 2. And the reason it did that is when we instantiated this up here, it actually put the number of sides in there, and then it also rolled the dice, and that's how we got the value 2. So we go ahead and we're going to step through this. It says rolling a 6-sided die. It rolls it, but now we have a 6. See the value up here is 6? Because it actually executed that roll method. And now we're going to display this. And it says the die's value is now 6. So we go back to the calling. Now we're going to call this again. So we step into that method. And it says it's rolling A. Now if I do this, I'm going to basically step into that. And it basically calls the get sides, and it returns the sides. And if I look at, remember I said the nickname for the current class you're in is called this. So if I look at this, I can see the sides has 20 and the value has a 2. So it's going to return sides. And when I basically execute that line, it says it's rolling a 20-sided die. So now let's call the D rolls. Let's step into that. So now we're over here back in the die class, because we're in the die object. And so now it's going to grab a random number. I'll expand this so we can see what's going on. Because right now it's a 20-sided die and the value is 2. So we're going to get a random number. Random now has a random number. And now we're going to basically take that ram.nextIndex, number of sides, plus 1, and throw it into value. And sure enough, we now have 18 in value. So we basically return back to the other program. And so now we call that get value. So I'm going to step into that. So here we are in get value. It's going to return value. Value has 18 in it. And now when I display that, it says the die's value is 18. And then it basically goes back, hits that, and stops the run. Does that help explain how that worked? You just don't. You'd have a hard time understanding what an object is. Okay, so let's go over that. So passing an entire object. So right here on line 15, we create this object called 6die. Now, there's a term called encapsulation. So think of this as basically this ball of stuff. And inside that ball of stuff are two instance variables, size and value. A method called roll, a method called getSize, a method called getValue. There's also a constructor called die that gets executed when this ball is created. Now what we're going to do is when I call this roll die and I pass this 6die, I'm taking this entire ball of stuff and I'm passing it. I'm actually passing the address down there, but down here it recreates that ball of stuff as D. So now I've got this ball of stuff that's got its own instance variables. Now what I want you to really understand is there's a huge difference, or there's a difference between 6die and 20die. Those are two balls of objects sitting here in this code. I've got one called 6die, I've got one called 20die. And when I'm down in here, when I call the getSize, it depends on what object I'm dealing with. And down here, when I call getValue, it depends on what object am I on the 6die or I'm on the 20die. I don't know. This method has to be generic enough to understand that basically it doesn't care what the object is. It only cares about the methods that basically go with that object. Okay. Correct. Well, that object. Remember, this class. This die class is a blueprint to create an object. So when I'm calling the method, I'm actually calling the method within the object, not within the class. Because this class, remember, this is just a blueprint. I create an object, it now has all of this stuff inside of that object. It seems kind of weird, but so this class created two different objects. We created a 6die and a 20die. Exactly. An object is created from a class. It's not a class. Does that make sense? Right. Right. Yeah, so because again, that object is encapsulated because again, it's got two instance variables that are holding data right now. Okay. So it's got its own stuff. And so, think about this. Think about an employee database. And every time we read an employee record, or, we create an object for that employee. And that employee is going to have their name, their address, city, state, zip, number of dependents, what they get paid per hour, how many hours they worked, their FICA, their all of those tax information. It's going to show their years of service when they started, all that kind of good stuff. And when I pass each one of those objects for that employee to that particular method, it's going to run against all of those methods that are basically inside of that object. So here's I want you to think about this way. This 20 size and this 6 size, the 6die and the 20die, when I create this guy from that object, it now has its own methods. And this 20die has its own methods. They're the same exact, they basically look identical as far as, the names of the methods, that type of thing. But the roll method in the 20die is completely separate from the roll die in this 6die. two separate methods. They look the same, they're spelled the same, but it has its own role, and the 20 die has its own role. Okay? Right. Well, again, you realize we're doing simplistic programming here for just so we can learn. But think of it this way: we might pass that object to a completely different project, and so that project is going to basically then take that data and do whatever it needs to do, and then do some type of so. For example, I've got that employee object. I take that employee object, and now I need to calculate the federal income tax. So I take that object, I pass it over to another complete project. You know, we have projects over here. I've got the Chap 3, Chap 4, Chap 5. I might pass it to a completely different project where they actually do the calculation. And once they do the calculations, reading all of that data that's inside of that object and calling all of those methods, it creates the federal income tax and then passes that information back to the calling the code that called that. So instead of doing all of the stuff here inside of this class, we're going to take that whole object, throw it over here in this other place. It does all the calculations and then passes that data back. And we'll probably have inside of our object, we'll probably have a federal income tax field, and we'll pass that whole object over here. It reads all of the data inside that object, calculates the federal income tax, sets that field, and then passes it back. Okay. And you got it? Okay. Did you see a chapter 6 inside of that chapter 6 folder? You can just delete that. Okay. Now, okay, so let's continue on, and this next section is kind of a fun section because it basically simulates this game called Chohan. I guess that's some kind of a Chinese gambling game where you basically flip over cards and things, and you have to bet whether it's going to be odd or even. And so let's do this. So we're going to basically have 1, 2, 3, I believe 4 different classes we're going to be dealing with. So let's expand chapter 6, expand the SRC, and we should see a Chohan folder. Let's expand that. And so the first thing we're going to look at is let's take a look at dealer. Let's open up dealer. And so dealer has 2 instance variables. It's got die1 value and die2 value. And you'll notice we do have a constructor. And you'll notice this is a no-ARG constructor, and look what it does. It initializes die1 value to 0 and die2 value to 0. So when this particular object is created, when a dealer object is created, it's going to call this constructor and set those 2 instance variables to 0 each of them. The next thing we have is a rolled dice method. And we come down here and it looks like we have a final int side. So we have a constant which has a sides value set to 6. We create 2 6-sided dies, it looks like, and we're going to pass this sides to it. So we're going to call die, we've got die 1 object and die 2 objects. We have 2 die objects. One is die 1 and die 2. And then I'm going to say die 1 value. So I'm going to set these values of our instance variables. We're going to set it to the die 1 get value, die 2 get value. Okay, so we know what the die does. So basically, it creates a die and rolls the dice, gets a random value between 1 and whatever the number of sides are, and we're basically good. Then we have this string. It basically looks like we call get, show, or hand, and it's going to return a string. The first thing we do is create a string called result. We've got an int sum equals die 1 plus die 2. So we add the 2 die values together and we put that into sum. Then here's what we do is we divide sum by 2, and when we divide, and we're doing a modulus. So if I divide sum by 2 and I get 0, that means it's even. So we're going to set the result to show even, else it's basically hand odd. And then we return the result. Okay? So there's get, show, or hand. And then we've got get die value, and we return die 1 value, and we get die 2 value, we return die 2 value. So the two main things we got going on here is rolling the dice, which basically utilizes the die objects, creates 2 die objects, and we get the values. And then we got get, show, or hand. It's going to take the 2 die value, add them together to get whether they're even or odd, and basically put that into result. That's all the dealer class does. So let's take a look at the player class. So this one now has 3 instance variables. It has string name, string guess, and int points. It does have a constructor. Remember, the constructor gets executed only once at instantiation. It is expecting a string to be passed to it called player name, and it's going to make the name instance variable equal to player name. The guess is going to be equal to a null value, and points is going to be set to 0. We then have a make guess method. It returns nothing. It's got a void. We create a rand object from the random class, and then I've got int guess number equals rand.nextInt2. So this guess is basically going to get a random number that's either 0 or 1. Okay? And that's going to be put into guess number. Then we're going to say if guess number equals 0, the guess is going to be made show even, or else the guess is going to be made to hand odd. So make guess is going to get a random number from 0 to 1. If it's a 0, it's going to set guess to show, else it sets the guess equal to hand. We've got an add points method. We're going to pass in new points as an integer. It passes back nothing. And it's going to take those new points and add them to points. We've got a get name, so it returns the name. We've got get guess, it returns the guess. Then we've got get points, and it returns the points. So that is the players. So if you notice, I want you to pay close attention to all of this stuff pertains to a player playing this game. The dealer, that pretty much, all this stuff that's in here pertains to what the dealer would have to, think about a dealer at a casino in Vegas. What do they have to deal with? Okay, well, they've got the dice. They're going to be rolling the dice. They're going to basically take and decide when I roll my dice, is it odd or even? When I add those 2 dice together, is it odd or even? And then I can get the die 1 value and the die 2 value. Okay? So that's the dealer and the player. Okay, good. So now let's open up the show hand. Now you notice that Chohan has a public static void main. Okay. So this is the guy that's going to kind of bring everything all together. So the first thing we do is we got a constant called max rounds, and it's set to 5. So we're going to play 5 rounds of this Chohan. We create a string player 1 name, string player 2 name. We've got a scanner keyboard, and we're going to basically ask the user via the scanner keyboard, enter the first player's name, and then we're going to grab that and throw it into player name 1. We're going to enter the second player's name. We're going to grab that and throw it into player 2 name. Then I create a dealer object. So here's my dealer. Dealer equals new dealer. If you remember with dealer, it does have a constructor, or it has a constructor where it basically sets each one of those die values to 0. So after I execute line 22, I now have a dealer object. Okay. Exactly. Within the constructor, I can do anything I want in that constructor. The constructor is like a method. I can do anything inside there. But what you want to think about is what you want in that constructor is what you want to do at the beginning of creating an object. You need to initialize variables like the die. You need to roll the die once so that you can at least get one value in that die, that type of thing. So. So you don't really want to do too much inside the constructor, but you can. It's just like any other method. You can do whatever you need to do. And like I said, we don't have to always pass something to the constructor. Like the dealer here, that's a no art constructor. There's nothing in those parentheses. But we come down here, now we're going to create 2 player objects. I got player 1 and player 2. Notice I'm putting the player 1 name in the constructor. Because if you remember, in the constructor, here it is. It takes the player name and sets out the player name. It sets the guess to a null value, and it sets the points to 0. Because we're going to be adding to the points, so we need to initialize those to 0. And that's another thing we can do in the constructor. If we have a totaling, let's say we have a variable we're going to do totaling, that's a great place to set that to 0, so we always have a starting point. So we have our 2 player objects. Now we have our dealer object, we have our player object. Now remember, inside that dealer object is also this die object. And I don't want to go into that because it's identical to everything we've seen before. Because remember, when I create that die, it basically, we bring in the number of sides, and then it does a roll and sets, so we get the value to put in that. So just instantiating the die, we tell it how many sides are on that die, and then we basically roll the dice so we can put a value in there. So so that's another thing because it doesn't create the die. It doesn't create the die until we call the roll dice. Yeah, that's what it does. Okay. So now we got our rounds. We're going to do our rounds. So we got a for loop. So here's our int round equals 0. While round is less than max rounds, which is 5, we're going to come into here. And at the end of each loop, we're going to basically add 1 to round. So in here, I go ahead and print a dash line, and then we have now playing round. And now it looks like we're using a printf here because we're going to put our round plus 1, because remember we're going from 0 to 4. Well, we don't want it to say 0. We want it to say 1 through 5. So we add 1 to round. So it's going to come in here and say now playing round 1, now playing round 2, now I'm playing round 3, so on and so forth. And notice I've got my /n because it's a printf. It's not a print ln. So then I come in here and I call the dealer roll dice. So here's my dealer roll dice, and remember what happens there? It creates a die 1 object and creates a die 2 object. Now, one thing I want you to pay close attention to, it is creating a new die object each time it calls roll dice. Because here's what I want you to think about. This guy is born here, and he dies right there. That's the life, that's the scope of that object. Die 2 object is created here on line 32, and it dies on line 37. Exactly. Because this is a variable. This is an object variable right here. It's born here, and it dies here. So every time we call this roll dice, 2 die objects or 2 die objects are created. They basically get a random number put in each one of those values. We then basically utilize those dice, because what happens is we basically get so all we're doing is this, is we create 2 die objects and we get the value from those die and put them into our values right here. We don't need those dice anymore. We got the values, that's all we need right now. Then I got player 1 dot make a guess. Now remember what that does? Is that grabs a random number, it's either a 0 or a 1. And if it's a 0, we're going to put Cho in the guess, or we're going to put Han in the guess. We do the same thing for player 2 as well. Then we basically pass, look at this, we're going to pass 3 objects to this round results. We're going to pass the dealer, we're going to pass player 1 and player 2. So I come down here, look at that, here's dealer, player 1, player 2. First thing we do is we see the dealer rolled D and D, and it's going to grab dealer.get die 1 value, dealer.get die 2 value. And we use a printf again, and dealer.get Cho or Han. Okay, remember what the dealer does for get Cho or Han is it basically takes those 2 die values, adds them together, divides by 2. If there is no remainder, it's even. If there is a remainder, it's Han. And it returns either Cho or Han. So we get that Cho or Han right here. So we're going to see the die values, and we're going to see Cho or Han. Then we're going to call check guess, and we're going to pass player 1 and dealer. So down here is check guess. Here's our player, and here's our dealer. And we've got a constant called points to add equals 1. And we got string guess equals player 1 dot get guess. We get players 1 guess, which is either Cho or Han. Because remember, it's either a 0 or a 1, random number. And if it's 0, it's basically a Han. If it's a 1, if it's a 0, it's a Cho. If it's a 1, it's a Han. And then we say Cho Han result equals dealer.get Cho or Han. So now I have guess variable and I have a Cho Han result. And I'll say the player's guess was player got get name. So we're going to get the player's name and then their guess. So the player, here's their name, guessed, and here's what their guess. Then we say if guess dot equals ignore case, Cho Han result. So we're going to basically take a look at those 2 strings, because remember we can't do the equal sign, we can't do an equal because strings are objects, but we can use the equals ignore case. So we check to see if the guess is equal to Cho or Han result. If it is, we're going to add points. Look at this. We're going to call the player dot add points. So whatever player whatever player got passed here, we're going to add 1 point to that player. And then we're going to display awarding blank points to get name. So it will say awarding 1 point to whoever's name that is. We come back from that. We hit that, we come back from that, and we're basically done with that round. And we come back through that loop again, and we do that again and again and again. Then, once we do all those loops, we're going to call display grand winner, and we're going to pass player 1 and player 2 objects to that. So I come all the way down here, display grand winner. Notice I got player 1, I got player 2. They're both player objects. I display a dashed line, and I say game over, here's the results. So it looks like we're doing a printf again. So here is S and D points. So player.get name and player1.get points. And then another printf, S and D, and we got player 2 get name and player 2 get points. So it's going to display the player's name, total number of points they got, The second one is the player 2 name, the points they got. If player 1.getPoints is greater than player 2.getPoints, we're going to display player 1.getName is the grand winner. Else, if player 2.getPoints is greater than player 1.getPoints, we're going to display player 2.getName is the grand winner. Else, both players tied. Whew! A lot of stuff going on there, isn't it? Well, the nice thing is we're passing objects, and we're saying, hey, use those methods from those objects to basically get the name, get the points, or add to the points, all that kind of good stuff. We don't have to... Right? Okay. Yep. Right. We passed in player 1 object right here. And so that's the player 1 that's getting passed to the check to guess method. Nope. Nope. Because this method right here, round results, only sees what it knows. And all it knows is dealer, player 1, and player 2. That's all that it knows. It cannot see anything else outside of that. Because remember, everything is local. This public static void main, it knows max rounds, player 1, player 2 name. It knows scanner keyboard. It knows the dealer. It knows player 1, player 2. It knows all that. But coming over here, does this round results know anything about scanner? No, it knows nothing about scanner. Does it know anything about, I think it pretty much knows everything else. Does it know max rounds? No, it doesn't know max rounds. So when it comes down here, it's going to pass just one of the players and dealer. So what we're doing down here in check guess, we're only dealing with one player at a time. So down here, does this guy know about player 1 and player 2? It doesn't know anything about player 1 and player 2. It just knows about the player that was passed to me. That's all it knows about. It goes, I know I was passed a player, that's all I know. I don't know if they're player 1 or player 2. I just know it's a player, and I know that we're going to get their guess, and then we're going to get the dealer's get, show, or hand, and then we're going to basically just decide whether they guessed correctly or not, whether they get a point or not. And down here at this display grand winner, now it knows player 1 and player 2. Does it know anything about dealer? No, it doesn't know anything about dealer because dealer wasn't passed to it. Okay, so let's run this, and then I'll try to step through it. So let's run it, and we'll do Alex and Brandon, and let's step through all of this. So player 1, dealer rolled a 5 and a 2, so it's a hand. Alex guessed hand, so got 1 point. Brandon guessed show. Brandon didn't get any points. So round 2, they got a 5 and a 4, which is odd. Alex guessed show even. Brandon guessed show even. Nobody got any points there. Round 3, dealer rolled a 6 and a 6, which is show even. You both guessed hand. Nobody got any points. Round 4, dealer rolled a 3 and a 4, which is odd. Alex guessed odd. Brandon, sorry, Brandon, you're not getting any points, brother. And then Alex got he got a point there. Round 5 is 6 and a 5, which is odd. Alex guessed odd, and wow. So Alex got 3 points. Brandon got 0. Alex is the grand winner. And if I ran it, I know. And if I ran it again, watch what happens. We'll do Alex and Brandon again. Brandon. Oh, Brandon got 2 points that time. Alex is still the grand winner. We'll just do this one more time. I'm hoping Brandon wins. Yep, Brandon's the grand winner. So Alex got 1 point, Brandon got 2. So let's kind of step through this. So I'm going to come down here and I'm going to put a breakpoint right here where we instantiate dealer. So I run it. So I'm going to enter so Alex and Brandon. Oh, I clicked ran, didn't I? Let me click your debug. There we go. So now here we are at dealer. So we look over here, we've got max rounds 5, we got player name Alex, player 2 name Brandon, and there's our keyboard scanner. So let's go ahead and step into dealer. So here we are at the constructor. Now if you look, I'm going to go to this. Notice die1 value that says 0, but it's really a null value right now. So we basically run this, so it sets 0 and 0. And then we go back. So we're back here. So now, let me step one past that. Okay. So now I have a dealer object over here. I expand that. I can see I have a die1 value of 0 and a die2 value of 0. So now we come in. So we go into player 1. We're going to create a player 1. We're going to pass in the name. Let's step into that. So if I look right now, I got player name, which is Alex. So that's the variable that's being passed into our constructor. So I step into this. It's now going to set. Now I'm going to expand this. Notice this guess is a null, name is null, and points is 0. That's actually that should be showing null as well. But anyways, so name now has Alex in it. Guess now has a different type of null value, and points has a 0 in it. So we go back, and now if I look, let me go one past that. Now I have a player 1 over here. If I expand it, I can see the guess, I can see the name, I can see points. I'm just going to step over this, and now I have a player 2, which has the guess is null, name is Brandon, and points is 0. So now we come into this loop. We come in and we're going to go ahead and print. So here I've got my first player's name is Alex, second player's name Brandon. We print that dotted line. Now playing round D. So let's see what that's going to display. Now playing round 1, because it's basically doing round plus 1. Round right now has a 0 in it. But since we added 1 to it, it's now round 1. Now we're going to call the dealer roll dice. So let's step into that. So I come in here. So here's roll dice. So I come up here. It's got a die1 value is 0, die2 value is 0. I now have a sides equal to 6. And now I'm going to create, I'm just going to do this for one. I'm not going to do it for both. So I'm going to step into the die1. And it's being passed sides. So here we are. So here, let's expand this. So right now, sides have 0, value has 0. I got num sides, which is being passed in as 6. So we step into it. Sides equals num sides. Look at that. Sides now has 6. Now we're going to go into roll. So I step into roll, and here it's going to create a random number. So rand, and now we're going to say value because rand that next, and we're going to add 1 to it because we want to make sure it's not 0 through 5, but 1 through 6. Step over that, and look at that. Value now has a 1 in it. Okay, so we go back to, goes back to die, the constructor. We go back, and now die1, let's go over that. So now I got die1, which has side 6, value 1. I'm just going to step over the second one. And now die2 has 6 sides, and it's got the number 6 in it. So now we basically say die1 value got get value. So it should say have a 1 and a 6. Look at that. So now I have die1 value has a 1, die2 value has a 6. And it got those from the actual object's get value method. Okay, so that's the roll dice. Let's go back. So now we got, so our dealer, we rolled the dice. We got the dice, which is a 1 and a 6. Now we're going to do a player make a guess. We step into that, and here we got a random. We create a random object. Let's take a look at this right now. Guess is 0. Name is Alex. Points are 0. So we step into that. We basically get a random number between 0 and 1, and we got 1. So if the guess is a 0, we're going to put Cho as the guess, else we're going to put Han. Look what happens. It's going to put Han in there because 1 is round. So look at guess. So now this object, guess, has Han in it. Name is Alex. Points are 0. We come back here. I'm just going to do player 2. I'm going to step over player 2. When I look at player 2 now, the guess was Cho, name Brandon, points 0. So now we look at round results. We're going to pass all 3 of those objects to round results. So we go into it. So here we are. We got our dealer, we got our player 1, we got our player 2. We're going to print dealer rolled a D and a D. We're going to get the dealer's die1 value, die2 value. And it says the dealer rolled a 1 and a 6. Now we're going to basically print result dealer.get Cho or Han. So let's step into that. So we go into the dealer object. We're going to get Cho or Han. So we're going to basically add those 2 values together. So it's going to grab die1 value, die2 value, add them together, put it into sum. Sum now has a 7. We're going to take sum divided by 2. If the remainder is equal to 0, it's even. It's not. It looks like the result's going to be Han, so we change. So result is now Han, and we're going to return the result Han. So we come back, and it says the result was Han odd. Now if we look, we can see that player 1 has a Han, and player 2 has a Cho. So now we're going to check guess player 1 dealer. So we're going to pass the player 1 object and the dealer object to this check guess method. So come in here. So now here I got my player, which is Alex, and here's my dealer. It's got the die values. So we basically create a constant called points to add, which is 1. And there's my string guess player 1.get guess. Let's step into that. So basically it comes in here and gets the guess. What is the guess? The guess is Han. So we get that. Guess now has Han. We get the Cho Han results. We're going to go to the dealer. So let's see what the dealer brings back. The dealer, so get Cho or Han. It's going to go through that whole thing again. I don't know why. So it returns get Cho or Han, which is Han. So the guess is Han, the Cho or Han. So now it's going to say the player S, guessed S, which is get name, get guess. So player Alex guessed Han. This is now if guess equals ignore case Cho Han. We're going to basically add 1 to, so we're going to do player 1 add points. So I step into that, which goes into player. And this, if I look at this, this is Alex. This is the Alex object. It's going to add 1 to the points. So now points have 0 in it, or I'm sorry, has 1 in it. We just added 1 to it. We go back to that method. We then execute awarding 1 point to Alex. We then come back to this method. We come back. I'm just going to, so we step into that one. I think I'm just going to let the rest of it run. And so now, so we just kind of see how that worked, how we stepped into each method for each object's class, okay? How the class for each object. Pretty complex, but the whole point of this exercise is how we can split this out. Each object has its own job to do. The dealer, there's dice, there's the die object, and the dealer rolls the die. Excuse me. The dealer rolls the dice, and then the dealer determines, is it a cho or a hand, when I add those two dice together. Then the player, we give the name to the player, the player makes a guess, and then the player has points. And then we have to check this, then we have to go against what the dealer had and what the player had and see, do they equal? Does the guess equal what the dealer basically rolled? If they are, then we award 1 point to that player. And that's in the player object. We do the adding of the points in the player object. So 3 objects. We've got a dice object, our die object, a player object, and a dealer object. And they each do their own specific job. And here's what's really nice about this, is that die object, it could be used in other programs that need a die. Okay? The dealer object, now again, it's kind of specific to cho or hand, but we could make it more generic. I could take this dealer object and I could get rid of this cho even and result hand. What I could do is just bring back whether it's even or odd. Or, go ahead. Okay, so to conceptualize this, it's good to think about breaking it up into the specific jobs. Okay, so kind of think of it that way. Does the dealer worry about adding points, giving points to a player? No. Does the player worry about the dice? No. So the die object has its own job to do. It's got a specific job. It just basically grabs a random number between 1 and whatever the sides are on this die. That's all its job's supposed to do. The dealer is supposed to roll the die and add them together. And then they will basically then say whether it's a cho or a hand. The player, all the player has to do is make a guess and then add points and then get points when it basically wins that particular hand. The calling program, Cho Hand, it's doing a lot of it does most of the heavy lifting. So it's basically doing most of the heavy lifting here, where it's basically calling each one of these methods and it's doing the adding of the points and that type of thing. It determines who got a point and who didn't, but it's using those objects to determine that. Whew. That was a lot. No, again, instance variables or variables, they hold the data. So in this particular case, the dealer has the die 1 and die 2 values. That's all the dealer's worried about. Okay. The player, they have to know the player's name, they have to know the guess, and then they have their total points. That's really all that they're worried about. And the die, on the other hand, the die only worries about number of sides and the value of the current die. That's all it's worried about. Exactly. Compartmentalizing. Yep. Compartmentalizing is a great term to use here. And bringing them all together. Think. Like the company that I work at. I work at State Farm Insurance, and we have programs where, think about policyholders. We have to know a lot about the policyholders. So what we'll do is we'll have the policyholder, we have all of their data, and then we'll have a car process where we'll have a car, and then we'll basically have an object where we'll create a car object, and that car is going to have all this information about number of doors and all that, and it's going to be pulled from some type of a database and pulled into this object. The risk value, all that type of thing. And so now, and part of that policyholder data is how many tickets they've got, how many accidents they've been in, all that type of thing. And so now one program, we might have an underwriter program where that person basically takes all of this data about the policyholder and they determine, are they a high risk? Are they a low risk? Are they a medium risk? And they will then put a risk value in that policyholder object. And so now when they basically go to get price, we might have a whole nother price project about how much they're going to pay per month. And it's going to bring in that person, and it's going to look at the risk value, and it's going to look at some other data, and then it's going to determine what their monthly price is going to be. And so then that's going to come back. So again, each one of these, so it's compartmentalized. It's broken down into smaller pieces. Because when I go to add a car to a policyholder's particular object, I don't worry about risk. I don't worry about all that. I'm just adding that. So if I'm an agent and I'm adding a person, I'm just worried about adding that car. Only when they go to process the risk value and how much you're going to pay per month on that particular policy for that car, that's going to be determined by the underwriting process. Those folks will use that process. So, it's kind of like the player here. This player is only worried about making a guess and adding points and getting the name and getting the guess and getting the points. That's all it's worried about. That's its only job. And the dealer, could I? No, I don't work anywhere in that area. So, in fact, don't tell anybody. I don't even have State Farm Insurance. Anyways, so that's a whole other story. Anyway, so so the dealer is only worried about rolling the dice and then getting show or hand, which is basically getting the values from the dice and determining that, and then it can return the die value, the die 2 value, and that's it. So this guy's not worried about player names. He's not worried about anything like that. All he's worried about is the dice and adding those dice together and determine whether it's odd or even. Okay, so on page 370, let's throw some more complex stuff at you. So on page 370, let me get past all this. We've got this thing called overloading methods and constructors. Okay, so here's what happens here. We can have 2 or more methods in a class that may have the same name, but their parameter list must be different. And this also applies to constructors as well. So probably the best thing to do here is just let's just take a look at the example. So let's take a look at bank account. So let's take a look at the bank account class. So here I've got public class bank account. It's got one instance variable, which is balance. Now the one thing I want you to pay close attention to is I've got a constructor called bank account, and it has nothing inside the parentheses. And if that one is called, it's going to basically, if I instantiate with no arguments, it's going to set the balance equal to 0.0. And then it's got, now look at this, it's got another bank account. Whoa, what's going on here? I have another bank account constructor. This one has a double in the parentheses. And down here I've got another bank account constructor. And it's got a string in the parentheses. Yeah, which is the same exact name as the class. Now here's the deal. Yes. Now here's the deal. Only one of these constructors is going to be called. Now what it does is it's going to look at what's inside the parentheses, and that is called the signature. This signature up here on line 15 is a null or a no arg constructor. So it has no arguments in the signature. Line 26 is a double signature. And line 37 is a string signature. So let's take a look at the class that's calling, or what is it called? I want to look at the calling program. Am I even close? Where am I? Okay. Yeah. Over here. It's called a count test. A count test. So let's take a look at a count test. So a count test is a public static void main. I've got string input. I create a decimal format object called $, and I'm going to use a JOption pane. So what is your starting balance? And I've got input. Now, what is this input right here? It is a string data type. Here on line 23, we're going to create a bank account object. It's called bank account equals new bank account and input. That is a string signature. So guess what happens? Only one of these constructors will be executed. The other two will not be. Because remember, our constructor only gets called once and only once at instantiation. So it looks at the signature, and look, here's a string signature. Look what it does. Is it takes whatever's passed in, this str value, it's put into a double.parse double, so it converts it to a double, and it puts it into balance. If we pass no argument, it sets the balance to 0. If we pass in a double, it just takes that value, that variable, start balance, and puts it into balance. Does this make sense? Sure. Right. No. A constructor cannot be called ever. The only time it gets called is at instantiation. It cannot be called. Well, what we'll see, I think in the next chapter, in the next chapter we will see how we can kind of sort of call a constructor. But for the most part, no, we cannot call a constructor. So So in this particular case, it's going to call this on line 61. It's going to call this constructor, and then the other two structures are just not used. They will never be used for this object. Now, if we come down here, notice I've got a deposit. It's got string, and up here I've got a double. This is called overloading. Only one of these methods will be called depending on the signature. If a double is passed in, this method will be called. If a string is passed in, this method will be called. Same thing with withdrawal. If I pass in a double, this withdrawal will be called. If I pass in a string, only this one will be called. So it looks at the, and here's set balance as well. A double and a string. And then get balance, that gets the data, so it doesn't have to worry about overloading. So overloading, so let me ask you this. Could I do this? Could I create a public void set balance string S? Can I do that? Nope. Because we've already got a string signature. I can't have two string signatures because it doesn't know which one to call. It was I don't know if I need to call this one or this one. So no, we can't. Overloading only works as long as the signature is different. So count now. So we basically are passing in a string, and that's totally fine. It can handle it. And this is how much were you paid this month. It puts that in the input, and then we call account.deposit input. So that's a string. So here's my deposit. Here's my string deposit. It's going to take this string, convert it to a double, and add it to balance. And then I got your pay has been deposited. Your current balance is $, and we're going to basically call the get balance, which is a double. And then we say input, how much would you like to withdraw? Again, that is also a string. I call the account.withdrawal input. And so which one's it going to call? It's going to call the one with the string signature. Public static void withdrawal string, which the first thing it does is it converts that string to a double and then subtracts it from balance. And then lastly, it says your balance is, and it will display your balance using the $. Format. And since we call the J option pane, we always use the system.exit0 to make sure that J option pane basically clears out. So to run it, we just run it, and we'll type in 1,000. How much were you paid this month? I'm going to say 400. Your pay has been deposited. Your current balance is 1,400. Click OK. How much would you like to withdraw? I want to withdraw 900. And it says now your balance is 500. So what we've seen in the past, especially using our scanner keyboard, or in the past when we use a J option pane, we always converted it to a numeric value, to a primitive data type before we actually passed it into that particular method or whatever we're creating. Here we don't have to. I can get a double, or I can get a string, and I can handle both with overloading a method. Yeah, there's a count test. Okay, we've already kind of covered this, but the shadowing, if I need, if I want to make sure I'm using a instance variable, I can always put the word this dot in front of it. And I will always make sure I'm using that class's instance variable. Because if I had, let's say I had this in my bank account, I'm going to call this balance right here. So now when I click, notice that when I click on this balance, all three highlight because they're all the same. So this is where I would need to put a this in front of that particular. So now this is, because notice how that's highlighted? If I scroll all the way top, look at that instance variable is highlighted. So I'm now dealing with that instance variable because I have the word this in front of it. Again, like I said, I can put the word this in front of all these guys to make sure that I know I'm dealing with the instance variable for this particular class, but I don't have to. Does it hurt to not do that? Doesn't hurt. You might have a method that has a whole lot of stuff in there, so you might put the word this in front of it to make sure that when whoever's coming in behind you knows that that is the instance variable that you're dealing with. So on page, let's see what page that is. On page 380, we've got this thing called packages and import statements. So we've kind of sort of talked about these things. But it says the classes in the Java API are organized into packages. An import statement tells the compiler which package a class is located in. So in Chapter 2, we were introduced to the Java API, which is a standard library for pre-written classes, or what I like to call the Java Bible. And so, like here, we've got this import java.util scanner. So what there's a Java package, and then there's a package called util inside of that, and then inside of that util is the actual scanner class. Okay. So Java is one folder and util is another folder, and inside of that util folder are all of these different classes. Now, we can be explicit and we can use what are called wildcard import statements. So when I do import java.util scanner, I'm being very explicit that I want the scanner class that's inside of that util package. Same way with the random. But I could use a wildcard statement. So if I were to come back over here, what was it, Chohan? Yeah. It's got the import Java util scanner. I could actually get rid of scanner here and just type an asterisk, and it's going to work just fine. The asterisk says grab everything that's inside of the java.util package folder. Now, is it bad to do that? No, it doesn't hurt, but you're grabbing a whole lot of stuff you probably don't need. So if you specifically want a scanner, that will basically, like I said, notice the scanner class is not, we're not getting a red squiggly line because the scanner class is inside that util. We're saying grab everything inside the util folder. So if I were to, let's see if we went out to the Java API. I'm in Python, that's wrong. So if I go into the Java API and I look up the java.util, I click here, this is all of the stuff that's inside of the java.util. Notice there's scanner, but all this other stuff comes with it. So when I did that asterisk, not only did I get scanner, but I got all of this stuff too. Well, and like I said, it doesn't hurt but you're getting a lot of stuff put into your project folder that you probably don't need. And again, it doesn't hurt. Uh, there's the Java Lang package, which is automatically imported to every Java program. This package contains several classes, such as the string and systems that are fundamental to the Java programming. So this is all. This is talking about all that stuff that automatically comes into, like the math. Math is in there as well. All that stuff is in that package, and that automatically gets imported behind the scenes. We don't have to do a java.lang package import. It's automatically there. So other packages that are out there is the java.applet. And if we wanted to create a Java applet, we basically can bring that in and utilize some of those classes. ATW is the abstract windowing toolkit. IO, we've kind of seen that. There's different inputs and outputs. The Lang, we just talked about that. .NET are for network communications. Security has a lot of built-in security features. SQL is for a sequential query language for dealing with databases. Text, the java.text has a lot of classes for formatting text. The java.util provides a various bunch of utility classes. And the .swing is basically for creating graphical user interfaces. If you take the Java 2 class, we actually get into the Java X.swing stuff for creating some really cool dialog boxes. Focus on object-oriented design, finding the classes and the responsibilities. So far we've learned the basics of writing a class, creating an object from a class, and using the object to perform operations. The first step to analyze the problem you're trying to solve and determine the classes that you will need. So first thing you got to do is find the classes. So when developing an object-oriented program, one of the first things we have to do is identify the classes we'll need. So over the years, software professionals have developed numerous techniques for finding the given class that is needed. So one of the popular techniques involves getting a written description of the problem domain, identifying all the nouns, refine the list to only include the classes that are relevant to the problem. So what this, I don't really want to go into this too much, but so here's how, so it says, okay, we've been given a problem. What classes do we need to create? Okay, so we've been given the job, Joe's Automotive. Okay, does it tell us what Joe's done for us? Let's see. Okay, so here it says, for example, suppose we're programming an application for the manager of Joe's Automotive Shop, and he'll use it to print service quotes for customers. Here's a description of the expert, perhaps Joe himself may have written. So we got to write a service quote. So once work gets done, we have to write a program that's going to do a service quote. So it says Joe's Automotive Shop services foreign cars, specializes in servicing cars made by Mercedes, Porsche, and BMW. When a customer brings a car to the shop, the manager gets the customer's name, address, and telephone number. Then the manager determines the make, model, and year of that car, gives the customer a service quote. The service quote shows an estimated parts charge, estimated labor charge, sales tax, and total estimated charges. So what we got to do is we got to take that paragraph and try to break down what is a class, what is an instance variable, what is needed, what is not needed. So let's kind of lay that out. So we've taken this particular paragraph, and everything that's bolded is a noun, and we're going to bring it down here into this list. So here's a list of all the nouns. Now, so some of the nouns really mean the same thing. Car, cars, and foreign cars are basically a car. Joe's Automotive Shop and shop, those basically refer to the company Joe's Automotive Shop. And basically Joe's Automotive Shop is really not needed. So we come down here, we can scratch out foreign cars and Joe's Automotive Shop, and we're going to keep shop. I guess we'll use the word shop. I guess we're going to keep the word shop. So, got rid of foreign cars, Joe's Automotive Shop, and cars. Now, some nouns might represent items we do not need to be concerned with for the problem. For example, manager. Do we need manager? No. Manager is something we don't need at all. Some of the nouns might represent objects, not classes. So Mercedes is a car. Porsche is a car. BMW is a car. So it looks like we're going to create a car object, but these guys are going to be objects. So we don't need to basically deal with we don't need to deal with them right now. So we're going to scratch off Mercedes, BMW, and Porsche. Some of the nouns might represent simple values that can be stored as primitive variables and do not require a class. So, address, estimated labor charges, estimated parts charge, make, model, name, sales tax, telephone number, total estimated charges, and year. Those are all going to be instance variables. So we're going to basically scratch all of those off, and when we get down to it, it looks like car, service quote are the only two classes we're going to deal with for this whole entire thing. So now we got to basically get the responsibility for those two classes we're going to create. Okay, the things that the class is responsible for knowing, and the actions the class is responsible for doing. So the things that the class is responsible for knowing, those are going to be our instance variables, and the actions that the class is responsible for doing are going to be our methods. So we got our customer class, and if we look at that, a list of those different variable names, we're going to have the customer's name, the customer's address, and the customer's telephone number. So what are the things we're going to do? Well, we're going to create a customer class. We're going to have instance variable, which is name, which is a string, address, which is a string, and phone, which is a string. We're going to have a customer constructor that's receiving nothing. We're going to have a set. We're going to have our 3 setters and 3 getters. It looks like I'm sorry, did I miss that? Yeah, I missed customer. Yeah. So we're going to create a car, a customer, and a service quote. Okay, so I missed customer. So the next thing we're going to create is the car class. So car, we're going to have our make, model, and year. Those are going to be our 3 instance variables. We're going to have a car constructor. We're going to have our 2 setters. I'm sorry, 3 setters and 3 getters. Okay. Set make, set model, set year. And we're going to get make, get model, get year. Then for our service quote class, we got the estimated parts charges, estimated labor charges, sales tax, and the total estimated charges. So we got our parts charges and labor charges, which is our 2 instance variables. We got our service quote, which is our constructor. We've got our 2 setters. We've got our 2 getters, or 3 getters. Well, we got our 2 setters that go with the actual instance variables, and then we got a get sales tax and a get total charges. Those are going to basically, remember our get area for our rectangle? Those are like that. And so then we've got these laid out. Now we can go in and create those 3 classes very easily. And in the get sales tax, we're going to have probably some kind of a percentage that we're going to have as a constant. And then whenever we get our total parts and our total, now we can't charge labor, we can't charge tax on labor. We can only charge tax on parts. We'll basically have a calculation inside of this get sales tax, which will basically then add money to our total charges, and that's what the total charges. So the total charges will then get the total parts, the total labor, the tax, add them together, and then provide that as our total. Pretty slick. Any questions on that?